What's up, guys? In this video we're going to make a simple poker game in Python. Each card is a tuple of rank and suit. The deck is a list of those tuples, and a hand will also be a list of those tuples, and then we'll make functions to handle each aspect. So let's go ranks, and this will be the rank of each card. We'll make it a single character, so like T for 10, so you don't have to worry about the 1 and the 0 getting stuck together. And then the suits, I think we can do some nice emojis. I think it's, yeah, Windows key semicolon if you're on Windows. And look, I've used them recently, so they're in there and you don't have to search. But if you do search, you can type suit and it'll come up with the ones you want. Now the only issue with those is that they print wider than a regular character. Even though this is trying to be a monospaced font, they stretch out, and we'll see if we need to change our spacing. Let's say print, what if we get one of each, you know? The card is going to be something like that. Okay. But the deck is going to be a tuple, and we're learning list comprehensions in class, so this will be a way to use a list comprehension to make a deck. Let's say deck 0. Now it'll look worse than this because now it's, instead of being a string, it's a tuple, which fits more with the idea of this being two separate things, kind of like a point having x and y. But it'll be ugly when we print it, especially if it's a list, and then it would have bracket, parentheses, quote, before you ever get to the data. So we'll make a function to print it nicely. But the problem is, once we start doing this, we're going to be doing different things for different types, like how do we get the rank of a card? How about the rank of a hand? Because when we say pair, 2 pair, 3 of a kind, that's also called rank. And how do we print them? Well, I think the best way to do this, and this is something new, is we're going to start separating them into different files. We haven't done this in class, but it'll be a nice way to get started. So I'm going to make a file called card.py for Python, and we'll put all the card stuff in there. So what do we need? If you have a card, I'm going to make a function called rank that'll return card 0. So if you ever want to get the rank, you don't have to remember what the number was or put brackets and worry about an index error. No, you just call rank. What's another thing we might need? Well, I think we need something that you can compare. Like right now with the rank, you can't say that J is better than 3 because that's not the default string compare or something. So I'm going to call that value. It's going to be like a number that we can use to compare. And the way we'll do it now is we'll look it up from the index. We could also turn this into a dictionary where like ace points to 14 or whatever. And that would work just as well. You know what? I was going to say card 0, but I could say rank of card using the functions we just made. And then I'm going to go +2. So like if I look up a 2, it would say 0 because it's first in the list, but I want it to say 2. And if I look up Jack, I want it to say 11 because it comes after 10. Okay. And finally, we need one to print it nicely. So you could call this like pretty print. That's a very common name. Or stringify. That's something they use in JavaScript. Well, why not call it stringify? And what it's actually going to be is just join, because these are already 2 strings. So now we can go, this is the same thing, but it's going to be, they live in the card file. Often in a lot of programming languages you would define a class and you would say, oh, there's a card class, and then you would say each thing has attributes and methods, but these are not that. This is just regular functions and regular variables that we have learned in class. So let's say, try that. It's going to look the same, but this is a test to make sure it works, and it doesn't because we're missing the next part, which is to import the card. Just like sometimes we've imported math or random or these built-in Python modules, you can make your own by just making a file. So hey, look, there we go. But we don't want that. We want card.stringify of this guy. And then, hey, look at that. It's nicer. If you had a bunch of them, you'd want it to be like that. So that's great. Let's make a deck file that will hold all the deck related stuff, like that. I guess it will import card as well. You do have to worry about circular imports, like if one file tries to import another and then back and forth, that's no good. But if card is just like at the bottom and everybody depends on card, that's fine, it'll work. So let's say I want to make a new deck. Let's have a function called new, and it'll return that. And now in our main file, we could just say deck.new, and we don't care how it was done, we just get the output. What are some other things you might do? Well, we probably want to shuffle, and this is going to import random, which means that the main function or the main file won't have to import random. They'll just say, hey deck, just do whatever you got to do. If you import stuff, that's your business. I don't have to worry about it. So let's say random.shuffle. This one's kind of weird because it doesn't return. It changes it in place. And I guess that saves memory so you don't make a new one, but it is kind of weird. And then finally, what's the main thing we do with the deck is draw. So we'll need a number, like how many? You rarely draw one, but usually we'll draw like 5 at a time to get a hand or something. So we'll go deck.pop, that's a list method for, I usually don't like to do I in range because then I start looking for where does the I come in, and if I don't see it, it kind of distracts me. So if I have a loop variable that never matters, we call it underscore, and then you know, okay, don't worry about it, it's just a placeholder. Now this has an issue of could create an error if deck less than amount, right? Like if the deck has 2 and we say give me 3, then that's going to be a problem. It won't right now because we're going to start with 52 and we'll draw for like 5 cards for a player, or maybe 10 or 15 for 2 or 3 players, but that's not even close to causing a problem. So let's go to the main and we'll go import deck, and we'll say like dealer equals deck.new, and then we'll go dealer, or we'll go deck.shuffle dealer, and then player equals deck.draw 5. Now this is what we'll call a hand, which is like a list of cards. And that looks terrible, right? It's not doing the nice string because we can't say card.stringify player. That only applies to a single card. So let's make one more file for the hand. The card, it's this. That's all we're ever going to need. By the way, the emojis are not printing right. That's an issue. I think if you hit backspace, it'll actually turn it into like the simpler, yeah. The emoji characters are sometimes more than one character. Like I think sometimes they have building blocks like face, happy, or whatever. And if you hit backspace, you can go to the more primitive version, which is actually better here. And that's all we're ever going to need in the card file, probably. Deck, that's all we're ever going to need as well. So even though we're making multiple files, it's not a big project. It's not like hundreds of lines of code. It's just a few. The hand is going to be a little more, because we're going to have to check for pair, two pair, three of a kind, etc. But first, let's say import card. We're probably going to need it. Does it need to know about the deck? No. Does it need to know about anything else? Probably not. Let's say I'm going to make one called stringify, like I did on the card. I think in one of my examples I called it pretty, because pretty print is a term people use. But anything works as long as it makes sense and it's consistent. So let's say hand, and then we're going to go probably space.join. One thing that I've talked about in class a few times, it wasn't in our lessons, but it's just a function I like, is called map. Map says, give me a function and I'll apply it to a whole list. Very similar to a list comprehension where you do something spread across a whole list. But the reason I like it is because you don't have to give a name to the individual parts. With the list comprehension, sometimes you say like thing for thing in things, and it feels weirdly repetitive, and you have the singular versus plural thing. But when you say map, you just give it a function in a list, and you don't have to name the individual guys. So let's try that. In here, we're going to go import hand, and we're going to go hand dot stringify player. So this is saying there's a stringify function that lives in the hand, not the one that lives in the card. Okay. And this should be a lot prettier. Ugh, beautiful. Okay, so this is why sometimes I call it, when I make a function to print something nicely, sometimes I call it pretty or pretty print, because that's what people call these kind of situations. So what do we need in the hand? Well, this is where we're going to say, okay, just like the card, what's your rank, which is a string, like the word flush or something. And then we'll also have one that's a number that can be compared, like we'll call it value maybe. However, just like the card, we're going to have a constant that's like listing them out in order. So let's go, instead of a big string, I'm going to do a list. So we'll say like no pair, or sometimes we call it high card. Like if you have no pair, you'll go, oh, I have a jack high or whatever. And we could change it so where that it actually looks at the hand and says, oh, you have a queen high or something. But for now, we'll just say no pair, and then two pair, and then three of a kind is next. And these are the most common. It's pretty rare to get anything beyond this, but it does happen. I think it's like 1% of the time you get each of these or something. I think we checked in class and it was like 2% to get a three of a kind. After that is full house. And you can see that a lot of these are just mix and match parts of each other. Like full house, that's just a pair and three of a kind. So if we know how to check for those, it's not really anything new to do another hand. And then you have four of a kind. And then the last one is straight flush. Now the best straight flush is 10 jack, king, queen, ace of suit. And some people call that a royal flush, which would be another name, but it's already the best because it's the best straight flush. So we maybe can give it a name or maybe not. It's okay. So if we imagine there's a thing called value, well, all we do is to say ranks.index rank of hand. Now we don't know what that's going to be yet, but I'm trying to follow the pattern of like, oh, I have a thing called rank that gives you a string that you can use to say, oh, I'm an ace or I'm a queen or whatever. And in the hand, you say I'm a pair or I'm a flush or whatever. And then we have a thing called value, which is a number that you can use to compare of, ace is 14 or flush is, 6 or something. And then we have a thing called stringify. So these are consistent, and you know that, oh, whichever one I'm dealing with, I can use the same names in the same way. They also have a constant all caps ranks if you wanted to get a list of them and so on. So we'll try to follow that on both. And these are just words I made up, like calling it a value is not part of the poker rules, but doing it once and then doing it again makes it predictable, so that if I remember, oh yeah, I can do that on both. So let's make the rank thing, and obviously this is going to be the hard part because we have to check for all of these guys. Okay, so in class we've done a couple exercises involving counting. We did one that was called word counts, and you take a piece of text and it's like, how many times does the appear and how many times does and appear, and those are pretty common. They might be 6 or 7. And then you have other words that are just in there once, like, you know, the name of a character or something. So you might say that counter would help here as well. We can do how many 7s, how many 8s, how many 9s, and then if one of them is a 3, then you have 3 of a kind, or full house, right? Now, we wrote that function, but Python has one built in. So I'm going to show you the built-in version. It does exactly the same as what we did. It just makes a dictionary with thing number. And you can go from collections, import counter. Or you can go import collections and then go collections.counter. It's the same thing. I'll do that just to follow the same as the other ones. So you can say, okay, I'm going to go collections.counter of what? Not the cards, because every card is unique. You'd have one of everything. But the ranks, because I want to see like how many 7s, how many 8s. Okay, so I'm going to go map of card.rank onto hand. So this is going to say, okay, give me just the rank using the 0. And then count those guys. So let's do it. This is obviously not done, but we'll print it to see what's happening on the screen. Do I need some parentheses? Yeah, probably. Okay. So let's say print hand.rank. Or we'll keep this. I don't want to change this. And it should say, you know, okay, we have 2 10s, which means, you know, we have a pair. So can we say if 2 is in there, that's a pair? Kind of, but we don't want to accidentally trigger that when it's really 2 pair or something else. And we actually don't know if it's going to be first. Like on these, the 2 happen to be first, and I think sometimes they organize it for you. But you don't want it to be like, oh, there's a 2 in the middle or something. So maybe we could sort? I don't know. What if we don't shuffle the deck? Then we'll get 4 of a kind, because it'll be like 4 aces on top. Okay. That's a test. I'm not certain. I think it looks like they're putting it number. Let's try it. I don't know if I want to do this unsorted, but we'll try. And then we're going to go dot values, because values is the right side of the dictionary. It's the things that come out when you put in the keys. So let's say counts equals that. Maybe should sort. I'm putting a note here. And then let's say return counts, just to make sure we didn't mess it up. I'm going to see if we, see, the 2 is not predictable. It might be in the front, it might be in the middle. So yeah, we should sort it. Like on that one, it's in the front, but not always. Okay. So, okay, sorted. And yes, that means we have a long line. But now it's guaranteed the 2 is always at the end, and if there was a 3, it'd always be at the end. And we could go the other way to make it at the front, but it's fine. But this line is long enough. Okay. So now we can say if counts is, then you're definitely a pair, because we've ruled out the other, like 1 1 1 2. That's just a pair. That's not a full house, right? Because that would be 2 3, right? And this is going to be a little annoying with the repetitive elif, 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 but that's okay. There's another way to do this with a Python statement called match, but we haven't covered that in class yet, so I don't want to do anything too new. We'll say, what if it's 1, 2, 2, then that's 2 pair. What if it's 1, 1, 3, then that's 3 of a kind. And the order doesn't matter in terms of too eagerly getting the wrong one, like we're not going to say pair when it was really full house. But, you know, I guess we should check the most common ones first, because if you check a pair and it's true, then you don't waste your time checking for a royal flush. What do we got here? We're not going to do the straight and flush in this way. It's not going to be based on counting, so we'll skip those, and then we'll do full house. And we'll do 4 of a kind. If you're doing a game with jokers, then it's potential 5 of a kind, but we don't have that here. Now let's do the straight and flush thing. We'll make a separate function for each one because they're kind of their own thing, you know. And this is a tiny bit wasteful if we call the function twice, like once for the straight flush and once for the flush. So we might make a way around it. But in this way, we get the benefit of just straight down the line. There's no deeper indenting or anything else. So it all follows the same pattern all the way through, which has benefits of its own to make it readable and changeable and everything. Okay, so the only thing left, if it never got any of those, is the no pair. Okay. Now, right now, if we try to run it, it's going to say, what do you mean there's no such thing as straight or flush? So we're going to have to fill those in. But let's just test it even without them for a minute. So this, hey look, that's a pair. That's a pair. That's no pair. Okay? And if we keep running it, we might eventually run into the others, but they are a lot less common. I think I said earlier that we found that 3 of a kind is like 2%. We could at least find a 2 pair. Or we could have multiple players, right? So we could say, oh, well, maybe there's an opponent. Same thing. And then maybe little string business. And then pretty soon we'll have to say who wins, right? Okay, maybe line break. Looks good, looks good. We're checking pair. Let's go until we hit a 2 pair at least. Can't be that uncommon. Oh, there's a 3 of a kind. That's pretty good. I'm worried about the 2 pair because I think it would have happened by now, so maybe we're unlucky or maybe I did it wrong. No, 1, 2, 2, that's what it would be, so, okay. Obviously we can do real tests, or we can sort the deck in a certain way, or we can just type out a hand. But that's pretty good. Let's do the straight and flush. So in class we had specific focus on these because we're doing a unit on comparison, sorting, comprehensions. And so Turns out the flush is a little bit easier. It doesn't need to sort. I guess it could sort, but here's what I want to do. I'm going to say suits is map of card.suit onto hand. Again, you could do this with a comprehension, totally fine. And you could turn it into a set, which is something that I don't think we talked about in class, but it makes a guaranteed unique sequence or collection where it's like, I don't care how many of each you just have one in the set. But since we haven't covered that, I won't use it. What we have covered is the unpacking, which I really like, which is like, what if you have the first suit and the other suits, and then you can see if they all equal the first. So you can say, okay, what if all suit equals first for suit and rest, which is like, we got the first and the rest, and if they all equal the first one, that means they all equal each other. And how can we test it? Well, it would take a while to get there. We could make a lot more players, or we could make the deck not shuffled, or we could sort it due to the suit. So we could go dealer equals sorted, key equals card.suit. That's another benefit of having these functions organized, is you can say, oh, I want to sort it according to some aspect of the card. And hey, look, they both got a flush. They're still jumbled. They're not a straight flush because they're still shuffled first, but then they're sorted again according to the suit. So that's a great way to test. How about the straight? Well, when we were talking about it in class, we determined that there's really a split. You could treat them as numbers and see if it's like 4, 5, 6, 7, 8, or 9, 10, 11, 12, 14. And the benefit of that is that they're easy to sort. There's no key involved. They're easy to see if there's a +1 difference in between each step. Or you could treat them as strings, and so you want to see if it's like T, J, Q, 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 K, A, and that's a little harder to sort. You have to use the key, but the benefit is you can check if that sequence is part of a big sequence. So let me show you what I mean. You can have like all straights is all of these plus, because in poker you can have the ace act as the top of the highest straight, 10, jack, king, queen, ace. Sometimes they call that Broadway. Or you can have ace appear as a 1, kind of like in blackjack. It could be a 1, where it's ace, 2, 3, 4, 5. So they call that a wheel in poker. So you can have ace, 2, 3, 4, 5, but I'm listing it as 2, 3, 4, 5, ace because that's how it would be sorted if we do them, you know? So it's a little weird, but hey, let's see. Have I gotten, I know this is kind of silly, but have I gotten this point with everything is a single word? I always love having a single word with no underscores, so I'm going to call it just straights with that. And then we're going to go, okay, join up the ranks and see if it's in there. See if like you have a 2, 3, 4, 5, 6, or a 7, 8, 9, 10 jack, or 5, 6, 7, 8, 9. Just like if that sliding window matches yours anywhere, which is a thing that strings can do. You can't do that with a list. You can't say like, is this small list sequence part of a big list, you know? So how can we do that? Map card dot rank on the hand, which you can see the parallel. It's like the same thing we did here. For the suits, for the flush, you're looking at the suits, and for the straight, you're looking at the ranks. The suit doesn't matter. You can have a straight with any matching, with any combination of, 2 clubs and 0 hearts and 1 diamond or whatever. But we're going to sort them. I guess we'll sort them first, because that's like one of these functions we have access to. Yeah, okay. I'm going to call this ascending, so this will be like the cards in ascending order, least to greatest, you know. And then return join their ranks in this thing. So this is like, okay, sort the cards so that they're in order, so it's like 6, 7, 8, 9, 10. Or even if it's not a straight, it's 6, 7, 8, 9, ace or something. And then take the rank, squish them together, so you have a stretch of this that's like 5 in a row. And the underscore doesn't matter because it would never happen. And then you check if that's in there. So let's try that. We're not going to get it. I don't know why I clicked run. We're going to get flushes, which are potentially a tiny bit likely to be straight flushes. But what if we sort due to rank? Is that going to work? Oh, well, no. That. Okay. What's going on there? Oh, because it's like sorting all the big guys together. Okay. So let's do this. Let's not shuffle and then sort by suit, which means it's going to be like the 2, 3, 4, 5, 6 of spades or whatever first. And we'll get a straight flush, which means we're testing the straight and the flush at the same time. Oops. So what's wrong here? Okay. Let's print to see what's happening. Print this. Because I think I got it, but obviously not, so see what happens. Hey. Oh. I didn't use the sorted version. Great. Done. That's what we're doing in class for this step of the project. And in our assignment, I've given you most of this and told you to fill in a few bits. The final step, the sort of final project for the quarter, is to add a tiebreaker. So what if you had a straight flush versus another straight flush? Who wins? Well, what if you had nothing versus nothing? You know, no pair versus no pair. Who wins? What if you had a single pair versus a single pair? Who wins? You have to look at something as a tiebreaker. So let's add a thing that's like actually checking that. So you could say winner equals, by the way, we talked about sorted and how the sorted function has a key parameter. Min and max have that too. So you can go max of player and opponent. And then you don't have to say like if, you know, if greater, if less, if equal. Key equals hand dot value. And then print winner. Now that's going to be the cards, not like the name. Okay. Whoop. Hand dot stringify winner. Is that what we called it? Yeah. Okay. Now we'll say print player if how about that? Yeah, beautiful. Okay, so this is totally good. 3 of a kind beats a pair. In fact, you don't even need to say the hand again because we just saw it 3 lines above. Was that 3 of a kind again? Oh. But this is not doing the tiebreaker correctly. So right now it says pair versus pair. I think the way it works is it would just default to the first one every time. So if it sees a pair, then that's the winner unless something else beats it, which the equal pair doesn't. our next step is we need to add a tiebreaker. So in here, we'll be like, oh, return that and the tiebreaker, which will be, guess what? Sorting, maybe sorting twice, because you have to get like, oh, I had pair of jacks and then ace king 4, and I'm gonna need to go jack jack ace k4 for the tiebreaker. So let's do it. While we're here, go ahead and finish up this video. We're gonna say I want to sort by the rank, but greatest to least, because I want the big ones first. So we're gonna go, what am I thinking of here? Counts equals collections dot counter. And yeah, you could say, hey, we've counted it once, can we like reuse that? Maybe, but to have it count 5 things is nothing for the computer. So we're going to count the ranks, which is like, oh, you have 2 jacks and 1 3 or something. And then we're going to use that in a second to sort them, because you're going to, oh, we want the ones that appear the most often. Like if you have a full house, we want the ones that you have 3 of, and then the ones that you have 2 of. Because if I have a full house of, 3 kings and 2 aces, and you have a full house of 3 aces and 2 twos, then you win, because the ace part matters, even though I'm sort of like better on average. Okay. So what are we going to do? We're going to sort. We want the values as well, which is like, sorted map card.value onto hand, but reverse. Reverse means greatest to least. And then we're going to go they need to be the same as each other, so you might as well use the value, because what's going to happen is when you give it the tiebreaker, it'll be like a list of 5 things, and the way that it works, if you do sort or max in our case, is that it just looks down the line. It's like if the first one is enough, that's enough. If the next one is enough, then there you go. .get is the dictionary method to get a thing, just like it sounds. But for now, let's print it so we can see what's happening. Because I think I got it, but who knows? I'm just making stuff up. Oh, yes, that's exactly what I want. So it's like pair. No, it's not. I needed to say reverse true. So I want the most plentiful ones to come first. Like if I have a pair of 8s, the 8s come before anything, even if there's an ace, right? There we go, pair. So I have 10, 10 at the beginning because I have 2 10s. Even though there's an ace after, that's only tiebreaker if it's me versus another pair of 10s. If it's pair of 10s versus pair of jacks, that matters more, even if they have like 2, 3, 4 as their other cards. Sometimes it's called the kicker. If you have a pair and then like other stuff, that's the kicker. Yeah, beautiful. So the 3s are coming first, even though we have bigger cards, because they matter more. But if it was a pair of 3s versus another pair of 3s, then the other cards would matter. And when this matters most is like straights and flushes, because there's a higher chance of a tie, right? Like if I have a straight and you have a straight, that's definitely a tie, versus like if I have a pair, if you have a pair, we probably don't need to look into the 5th card or whatever. So, hey, that's perfect. It was only 3 lines, but they are by far the most complicated. For sure, we haven't had to do reverse sorting, or we haven't had to sort the same thing twice until now, except when we were sorting the deck in weird ways to do our tests. But that's perfect. Now we can remove that print, and now we've got a poker hand versus another one. It checks for all the hands, and it makes them pretty, and it breaks ties, and we could add more. You could have a list of players. You could have up to 10, right? Because if they each get 5 cards and there's 52, who knows? Go from there. Add in a draw, add in community cards, do whatever.